Hey guys, so this is part two of my special segment. This is Mr. Parsons. This is my mom, Bobby.
Hi.
So I'm going to give her another 15 seconds to say something about me that you guys probably should know.
Okay, let me think. 15 seconds. He's a third child with third child qualities.
What does that mean? You're a third child.
I know. We're good.
Yeah.
A little outgoing.
I'd like to know more about this.
A little outgoing. Let me see. What else did he do? He cross country skied when he was in high school. Pretty good golfer. Broke my coffee table. Yes.
I didn't just break it. I
Yeah.
crushed it.
He's broken a few things of mine, but in general, he's a pretty good guy. I'll keep him.
And I always fix what I break.
Yes.
Anyway, say hi to my mom. All
Hi,
right,
guys.
and on to the extension notes. So these are systems of inequalities with three variables as opposed to just two. So the easiest way of solving this is elimination. Okay, we want to eliminate as many variables as possible. So I'm going to number the equations 1, 2, and 3 so I can talk about them. So you see how equation 3 is x minus z and all the rest are x plus c, or plus z. So I'm going to add equation 3 to both equation 1 and equation 2. And they're going to create new equations. So when I add them together, that's going to create a new equation, 2x, the y, there's no y, equals 8. And then when I do the same thing with 2 and 3, okay, again I erase all my previous work because now I'm starting anew. And I add the x's, okay, so it's going to be 4x minus y equals 10. Now I have two new equations with a plus and a minus on the y's. So now I can eliminate those by adding them together. Okay, so I'm going to take the new equation 1 plus the new equation 2, and I'm going to get 6x equals 18. Now I know x is going to be 3, and I've solved for one of the equations. So now I can plug that back in to the third equation because that's the easiest one. Okay, so 3 minus z equals 2. Subtract 3 on both sides. Left with a negative z or an opposite of z. So z has to be 1. Now I can take both of those and plug them into the easiest equation. I think the first equation is the easiest one. So I can now solve for y. 3 plus y plus 1 equals 6. I can combine like terms, or I can also figure out that y is going to be 2. Okay, so now I've solved for all three variables. Okay, and hopefully in the future we'll talk about graphing in 3D. It's again a vertical or a spatial axis. So I'm going to do 1 plus 2. I'm going to get 5x plus z equals 2. And then I'm going to do 3 plus 2, which is going to be 6x minus z equals negative 13. So now I have the z's as opposites. So now I'm going to add those together. We're going to get 11x equals negative 11. I'm going to divide by 11. Again, x is negative 1. So now I'm not going to plug that into the old equations. I'm going to plug it into one of the newer equations that I have, because those are still valid to use. I can plug it into any of the equations, and I can still get the same result. I'm going to get z equals 7. So now I take both of those and I plug it into one of the originals because that has the x, y, and z. So I'm going to choose the one with the least number of negatives. They all have negatives, but that's my suggestion to you. And that is going to solve for y. So I mean -4 plus y minus 21 equals -21. Y minus 25 equals -21. So y is going to be 4. So now I've solved for those. The next step is application problems. So these are, again, 3 variables. Okay. In this case, balls, bats, and bases. So I'm going to say x is a ball, y is a bat, z is a base. I'm just going to create equations based on that. So 10x plus 3y plus 2z equals 99. Total cost for all that stuff that I added together is 99 bucks. Second step, second equation, same process. 4x, 8y plus 2z equals 78. Because again, the total cost is found by finding all of them, adding all the prices that I got from each individual thing. Now the trick is to eliminate. Okay, so one of the first things I'm going to do is I need opposite signs on something. Okay, now I can multiply any of these. Okay, I'm going to choose the easiest one. So I'm going to try to eliminate the first two. So I'm going to take the first equation and I'm going to subtract the second equation, or change those signs for the second equation. Okay, because there's a 2z and now a negative 2z. So we're going to create a new equation, 6x minus 5y equals 21. The trick comes with the third equation. Again, I want to eliminate the z because I eliminated it already. So what I'm going to do is I'm going to take that third equation and I'm going to multiply it by a -2. Because that -2 is going to make that a -2z, and then I can add those together, cancel out. So I'm going to multiply everything by -2, create a new equation. Need a little room. So now, if I take the second equation and the third equation, I'm going to add those together. And what's going to happen is those x's are also going to cancel. I got lucky. Okay, I'm going to still be left with 2y, and that's going to equal 1080. And now I just divide by 2. And I got y is 5.4. Now I take that, I can plug it into this new equation over here. Solve for x. And then after I solve for x, again, I take both my x and my y, and I plug it into one of the original equations, and I can solve for z.